There is another important technique for regularization that only emerged relatively recently and works amazingly well. It also looks insane the first time you see it, so bear with me. It's called Dropout. Dropout works like this. Imagine that you have one layer that connects to another layer. The values that go from one layer to the next are often called activations. Now take those activations and randomly, for every example you train your network on, set half of them to 0. Completely randomly, you basically take half of the data that's flowing through your network and just destroy it, and then randomly again. If that doesn't sound crazy to you, then you might qualify to become a student of Geoffrey Hinton, who pioneered the technique. So what happens with Dropout? Your network can never rely on any given activation to be present, because they might be squashed at any given moment. So it is forced to learn a redundant representation for everything to make sure that at least some of the information remains. It's like a game of whack-a-mole. One activation gets smashed, but there is always one or more that do the same job and that don't get killed. So everything remains fine at the end. Forcing your network to learn redundant representations might sound very inefficient, but in practice it makes things more robust and prevents overfitting. It also makes your network act as if taking the consensus over an ensemble of networks, which is always a good way to improve performance. Dropout is one of the most important techniques to emerge in the last few years. If Dropout doesn't work for you, you should probably be using a bigger network.